Imagine a creature so violent that it punches with the force of a speeding bullet, so fast that your eyes can't even track its movement, and so alien that it sees colors beyond human comprehension. Now imagine that this apex predator is smaller than a pencil and looks like a rainbow-colored shrimp. These aren't fantasy monsters from some distant planet. They're mantis shrimp, and they might just be the most impossibly engineered animals on Earth. Picture this: a 4-inch crustacean that can shatter aquarium glass, create temperatures hotter than the sun's surface, and process visual information faster than any supercomputer. Sound too crazy to be real? Welcome to the mind-bending world of mantis shrimp, where the laws of physics get bent and broken by creatures that evolution seems to have designed while completely off its rocker. But here's what'll really blow your mind. These Technicolor murder machines have been perfecting their impossible abilities for over 400 million years. That's longer than trees have existed on land. And every single adaptation they've developed is more extreme than the last. Ready to dive into the most insane biology lesson of your life? Scientists recently discovered a whole new category of life called the ultrafast. Forget cheetahs. Forget falcons. Forget anything you thought was quick. The ultrafast club is populated by creatures that move so ridiculously fast that special cameras had to be invented just to see what they're actually doing. Trap-jaw ants that snap their jaws shut in 0.3 milliseconds. Fungal spores that launch at accelerations of 180,000 times gravity. And sitting pretty at the top of this impossible list, mantis shrimp. Their clubs rocket forward at 31 meters per second. That's 70 miles per hour underwater, where resistance should make that speed physically impossible. To put that in perspective, if you tried to punch something underwater, you'd be lucky to reach 2 miles per hour. These little rainbow warriors are hitting 35 times faster than humanly possible. The acceleration of their strike matches a .22 caliber bullet being fired from a gun. Except bullets don't have to deal with water resistance, and bullets definitely don't weigh more than the projectile they're firing. Professional divers who've encountered mantis shrimp describe the experience like getting hit by an underwater baseball bat, swung by an invisible giant. Aquarium owners have watched in horror as their glass tanks, thick enough to hold thousands of gallons, suddenly spiderweb with cracks after annoying their colorful little residents. But the truly insane part? The speed isn't even their most devastating weapon. That's where things get absolutely bizarre. When scientists first started measuring mantis shrimp punches with high-tech equipment, something completely up in their data. Something completely unexpected. Instead of one impact spike, they were seeing two. The first spike made sense. That was the club hitting whatever poor shell was about to become lunch. But what was causing the second impact? The answer would rewrite what we thought we knew about underwater physics. High-speed cameras revealed the impossible truth. After the club strikes, it rebounds so incredibly fast that it creates a region of ultra-low pressure in the water. And here's where physics gets freaky. When pressure drops that dramatically in water, the water doesn't stay liquid. It instantly vaporizes, creating what scientists call a cavitation bubble. This isn't just any bubble, though. When the surrounding water pressure collapses that bubble, it releases energy so intense that it reaches temperatures of 4,000 degrees Celsius. That's nearly as hot as the surface of the sun. Let that sink in for a moment. A 4-inch shrimp is creating solar temperatures in the middle of the ocean. The collapsing bubble doesn't just produce heat. It generates light bright enough to see with the naked eye, sound loud enough to stun fish, and a second shockwave that hits the prey like getting punched twice by the same fist. It's like they've weaponized a tiny underwater nuclear explosion. Dr. Sheila Paddock, the scientist who first captured this phenomenon on camera, described seeing these cavitation bubbles as absolutely thrilling because the technology to witness such impossible physics had only just been invented. But here's the kicker. Mantis shrimp don't just accidentally create these bubbles. They've evolved specifically to cavitate on command. Every single strike produces perfectly timed bubbles. It's not a side effect, it's a feature. This incredible discovery led researchers to uncover something even more mind-blowing about mantis shrimp evolution. Around 400 million years ago, the ancestors of modern mantis shrimp split into two completely different approaches to underwater carnage. Some became spearers, stealth assassins with curved, razor-sharp appendages designed for precision strikes. Others became smashers, demolition experts with club-like weapons built for pure destructive force. Here's where evolution gets wonderfully weird. You'd expect the fastest animals to hunt the fastest prey, right? Wrong. The lightning-quick smashers almost exclusively hunt the slowest creatures in the ocean: snails, clams, and oysters that can barely move. Meanwhile, the relatively slower spearers go after some of the ocean's speediest targets: fish, crabs, and octopuses that can dart away in the blink of an eye. This seems completely backwards until you understand the method behind the madness. Zebra mantis shrimp, the largest spearers, grow up to 15 inches long and hunt from sandy burrows with only their alien eyes poking out. When an unsuspecting fish swims by, the spear shoots out at 230 meters per second. Not as fast as their smasher cousins, but fast enough to impale fish on 10 sharp spines before they can react. The curved design of their spears, unlike straight stingers, helps them hold on to struggling prey. But the smashers? They need their prey to sit still for a very specific reason. Watch a purple-spotted mantis shrimp preparing to break open a snail shell, and you'll witness one of nature's most calculated acts of violence. First, it carefully positions the shell with its other appendages. It taps the shell with its antennae, almost like a quality control inspector. Then it seems to pause, waiting for something. That pause is everything. What looks like hesitation is actually the most crucial moment in the entire process. The mantis shrimp is winding up what might be the most sophisticated biological spring mechanism ever discovered. Hidden on top of their club is a saddle-shaped structure made of chitin that works exactly like a medieval crossbow. The shrimp's muscles slowly compress this biological spring and hold it in place with a latch mechanism that would make engineers weep with envy. When it's time to strike, that stored energy releases all at once. It's the same principle as using a bow to launch an arrow versus throwing it by hand. The energy input is identical, but the explosive release makes all the difference. Dr. Maya DeVries, who has spent years studying these creatures, explains it perfectly. They don't actually use much energy at all. They just release very little energy over extremely short periods of time, which creates that explosive effect. The engineering of their clubs is equally mind-blowing. The exterior is covered in a crack-resistant coating that works like the hand wraps boxers use to protect their knuckles. Underneath are two regions of fibers aligned in different directions. One area dissipates the shock of impact, while the other prevents the club from expanding and losing structural integrity. This means they can hammer away at clamshells or even aquarium glass thousands of times without damaging their primary weapon. But the clubs serve purposes beyond just hunting. Since smasher mantis shrimp live around coral reefs and rocky areas, prime real estate is incredibly limited. They need burrows big enough to fit their bodies, but small enough to block the entrance with their armored tails. This has led to some of the most violent property disputes in the animal kingdom. Researchers discovered that mantis shrimp actually put more energy into their territorial fights than they do into hunting strikes. These aren't just casual disagreements. They're full-scale wars where the loser might end up losing their home, their limbs, or their life. Some species of smashers even use their clubs as construction tools, literally punching perfect little apartments into solid coral formations. Dr. Paddock has been on the receiving end of mantis shrimp aggression more than once. You do have to be careful. The bigger problem is the spike at the end of their appendage. If that goes into your skin, it's really unpleasant. But honestly, they don't even want to spear you, because if they get their appendage stuck in your skin, they're gonna lose it. All of this incredible weaponry would be useless without the sensory equipment to aim it properly. And this is where mantis shrimp go from impressive to completely alien. Their eyes are so advanced that calling them the most complex in the animal kingdom doesn't even do them justice. While humans have 3 types of color receptors, mantis shrimp have between 12 and 16. They see ultraviolet light and types of polarized light that we didn't even know existed until we studied them. Each eye moves independently and has trinocular vision, That means each individual eyeball has depth perception that's better than human binocular vision. Combined, they have what researchers call hexnocular vision, a six-eyed view of the world that processes information so fast that much of it gets handled in the eye itself before even reaching the brain. The middle section of each eye contains thousands of specialized photoreceptor cells, arranged in 6 precise rows. These cells can detect linear, polarized light, diagonal, polarized light, and even circular, polarized light, where the light waves spiral like a corkscrew. Mantis shrimp are the only animals on Earth known to see circular polarization, and scientists think they use it for secret communication that's completely invisible to predators. But here's the plot twist that nobody saw coming. Despite having the most sophisticated color vision system ever discovered, mantis shrimp are actually terrible at distinguishing between similar colors. Researchers trained mantis shrimp to recognize different wavelengths of light and found they need differences of 50 to 100 nanometers to tell colors apart. Humans, with our pathetic 3-receptor system, can distinguish wavelengths that differ by just 5 nanometers. The explanation is beautifully simple. Human color vision works like a sophisticated mixing board, blending signals from our 3 receptors to create millions of perceived colors. Mantis shrimp vision works more like a piano. Each photoreceptor is a separate key that plays its own distinct note. This system is much faster and requires less brain power, perfect for creatures that need split-second identification of threats and prey. Their eyes process so much information so quickly that they have a special structure called a reniform body, a kidney-shaped region in their eye stalks that acts like a biological graphics processing unit. This pre-processes visual information before sending it to the brain, allowing them to react to threats and opportunities faster than should be physically possible. These incredible adaptations haven't just amazed biologists. They've inspired entire fields of human technology. Materials scientists are studying mantis shrimp clubs to develop new types of flexible armor that can absorb massive impacts without crack. The layered structure of their clubs has already influenced the design of everything from motorcycle helmets to body armor for soldiers. Roboticists built a 1.5-gram robot that mimics the mantis shrimp's striking mechanism. While it can punch faster than any similar-sized device ever created, it still can't match the speed of the real thing. Engineers are working on scaling up the technology for applications ranging from construction tools to emergency rescue equipment. The optical innovations inspired by mantis shrimp eyes are perhaps even more exciting. Researchers have developed polarization cameras that can see through water better than any previous technology, perfect for underwater exploration and marine biology research. Medical researchers are exploring whether mantis shrimp-inspired imaging could detect cancer cells before they begin to spread, potentially revolutionizing early diagnosis. Some of the newest cameras based on mantis shrimp vision can detect 12 different types of information from a single image: color, polarization, depth, movement, and more. These cameras are already being used in satellite imaging and may soon help self-driving cars navigate in conditions where traditional cameras fail. But perhaps the most exciting discovery came just recently. Scientists found that mantis shrimp eyes contain twice as many light-detecting proteins as they originally thought. We still don't understand what all these proteins do, but each new discovery opens up possibilities for technologies we haven't even imagined yet. The story of mantis shrimp is ultimately a story about the incredible creativity of evolution. Over 400 million years, these creatures have independently invented solutions to problems that our best engineers are still struggling to solve. They've created biological springs that outperform mechanical ones, optical systems that surpass our most advanced cameras, and weapons that harness physics in ways we're only beginning to understand. What started as a simple shrimp-like creature has evolved into something that seems more like science fiction than natural history. They punch with the force of bullets, see with alien precision, and create temperatures that rival stellar surfaces, all packed into a 4-inch package that looks like it was designed by someone with a serious rainbow obsession and a twisted sense of humor. But here's the truly mind-bending part. Mantis shrimp represent just one tiny example of the incredible diversity hidden in our oceans. Well, if creatures this impossible can evolve in shallow tropical waters, what other physics-defying animals are waiting to be discovered in the deep sea? What other impossible adaptations are evolution cooking up in places we've never thought to look? The next time you see a nature documentary or visit an aquarium, remember the mantis shrimp. Remember that sometimes the most incredible stories aren't found in fantasy novels or science fiction movies. Sometimes they're found in 4-inch rainbow crustaceans that punch harder than bullets and see colors that don't exist in human language. Sometimes reality is so much stranger than fiction that fiction seems boring by comparison. And somewhere out there in the vast blue expanse of our oceans, evolution is still experimenting, still pushing the boundaries of what's possible, still creating new impossibilities that will make the mantis shrimp look downright ordinary. The only question is, what incredible creature will we discover next? That's a wrap on today's wild journey. But here at the Zoo-phoria show, we're just getting started exploring nature's most incredible stories. Subscribe if you want to keep discovering the shocking, hilarious, and downright unbelievable truths about the animals sharing our planet. Your next favorite animal fact is just one click away.